task. That means, of course, for most, the easiest way is to use some of the basic packages like the Ivision Basic, Standard, Professional, or 3D Area, 3D Profile, Thermal, Hyperspectral, and some smart cameras. To explain it more, the basic version has this basic infrastructure of the software, and you can add to this all the commands you need. For example, if you want to make a solution where you need 2 3D commands, you could start with the basic version. Of course, the basic version is the cheapest one, as well, and add only these 2 commands. Or you can, if you have, you need a bunch of tools and you don't know exactly which one, then maybe the 3D area fits if you work in Pointclouds. So the packages belongs always to what we realized the customers need. And therefore we realized some of the customers work in Pointclouds and some in profiles, only profiles. So they use mostly profile sensors. There are a lot of applications which can be solved with profile. So that's why we made this ready-made profile solution. But you can also combine to the Pointcloud profile tools if you need. And I think now it's evident that you see thermal and hyperspectral means you have the tool set for thermal thermal imaging, or for hyperspectral if you use this. And finally, the other 2 are bundles. That means, I can show it to you later, you get the software with the hardware. That means we have different smart cameras. These are, I can go to the next slide. These are like the here in the middle section. We have much more. I highly recommend to have a look to our supported hardware presentation, where you find all the different hardware products which we support, especially also the embedded systems based on ARM, or of course smart cameras are embedded system, but also PCB-based embedded system, not only PC based systems with an Intel or AMD CPU with an x86 compatible CPU, let's say this way. So, and the bundles are iCheck or iSense. That means we sell the software with this ready-made integrated in this hardware as a finished tool. So you can, let's say it's compared with the vision sensors. I have to move this over. You can compare it with the different vision sensors or smart cameras from some of our, let's say, competitors, like maybe IFM or so, or SICK or Keyence on one or whatever. But mostly you get software only exactly. Sorry, I got a message from Zoom. I hope you can hear me all, because this message is a little bit strange. So anyway, yes, the difference between our competitors is whatever hardware you use, you have exactly the same software, which makes it much easier to do solutions, because if you know how to make it with a gray camera, you can do it with 3D, of course, with different tools. This is only as a short explanation about the Ivision. And of course, you get the software in these different languages, so that we can cover, of course, most of our customer regions with the software in their localized language. So maybe to finish up this one here means, if you what hardware fits best to your needs depends on your task. That means we don't say you have to use a PC and, let's say, whatever GigE camera from whatever manufacturer, or USB 3 camera or Co-Express camera or whatever. You are free to select the fitting hardware for the task. So we are happy to help you if you need help. we are happy to help you to find out the fitting hardware. For many cases, different hardware components fit for the solution. Yes, here a short overview of the industries where the software is used right now. It's from all major manufacturing areas, from semiconductor, automotive, electronic, pharma, food, of course, beverage, rubber, wood, and so on. The interesting thing on the other side is, and I think most of you might know it, is that it's always a similar task. Either you do measurement or you do detecting, like matching in 2D or in 3D, or also in temperature images, or you search for parts and so on. So this is what the tools can do. So it's not, the Ivision is not a ready-made solution for a special task. It's a tool which you can do, solve all the tasks. And the projects which I mentioned before, which you can download, shows you for the different industries ready-made solutions. So we can have a look later, maybe for in 3D for the pin inspection as one example. Then you will see, okay, similar tools, you can realize a pin inspection where you can do on the other side counting of bake rolls. It's similar based on the algorithms. So yes, and we're not so sure where we will exhibit this year. What we have definitively booked is the Vision show in Stuttgart, and we are totally sure that we go to the ITE show, and we have the virtual Automate Virtual in Detroit, in the USA, wherever it is. It's also booked. We just waiting for the control show, and we hope to be on some additionals, but right now it's really difficult for us. Maybe we are also on the embedded show next week, when we show some of the embedded stuff we have developed in the last few months. Yes, so let's go to our today. Oops, I cannot go there. To our presentation from today. And I just told you what I want to tell you in the next few remaining minutes. So at the end, you will see here, this is a screenshot, but you see it live in a few minutes. This is some measurement in a point cloud. And I will show you, you can do it in point cloud, or sometimes it's better to do it mixed, half point cloud, half 2.5D. We have all the measurement tools are available in 3D, but we have also the 2D, of course, to operate on gray or color images, or also on temperature images. But today the focus is more on point clouds. And one of the major things is, how do we get the point cloud into the system? And therefore, one of the main steps would be, what hardware do we support for 3D especially? As I mentioned, we have a complete overview about all the other hardware. So you can see here, if you have, we see it also in live, we have this really large 3D instruction set, which enables you to do all the stuff we can do in 2D, also in 3D. On the left side, you see here, this is the 2D instruction set, and you see, of course, we have much more other instructions, which belongs to the software, especially also communication stuff and so on, to not only do the image evaluation. Of course, it's always necessary to integrate the software into any kind of system, like PLC, or maybe a SCADA system or whatever. So we have all the standard communication protocols. Maybe we can have a look later on the communication. There you will find OPC, UART, Profinet, Profibus, Modbus, and the other stuff, and TCP/IP and RS-232, of course, to give you a short overview. And we also do support all the other things. That's why I really recommend to have a look first, maybe onto the videos of the last 2 webinars to get a nice intro. But if you don't like these videos and maybe you don't have so much time, we have very short videos in our YouTube channel where you find also a lot of information about how to use the software, how to do communications, and so on. Yes, the next step, the data streams. Of course, if we have a look to a 3D, the main data streams for 3D are either point clouds. Of course, I have in the first point here profiles, because in some cases the profile is a predecessor of a point cloud. If you collect profiles, you get a point cloud. But there are a lot of ready-made point cloud sensors, single shot sensors, and one of the, I would say, best known or well-known ones is the RealSense from Intel, for example. This is also a real nice sensor to give an overview about all the different optional streams I have here. For example, the point cloud image and also the color image with the sensor transfers. But beside of this, he could also transfer the depth image and the gray image, which enables you to do a lot more than only doing.
Ja, hallo.
Hello?
Ist okay. Ja, ich wollte von euch wissen, wie das gestern gelaufen ist.
Gestern gelaufen ist? Ich kann jetzt, ich glaube, maybe, so maybe you don't speak with me, I think so. So
okay, aber das heißt, ja.
Okay, so I think,
okay. Ja, gab es da keine Fragen oder Kommentare? Okay, aber
I think for the moment I go ahead, and if you have more questions, maybe you write it in the chat group. Then in the meantime, I go ahead with our presentation, because we don't had yesterday. Maybe you had yesterday the direct. You had the direct session with one of our engineers. Maybe, I don't know. Yes. Feel free to write me a short message and I can answer this also. Yes, let's go back to the RealSense. It's not the best sensor, but it's nice to show a lot of different data streams. And this is one of the things how the Ivision software works. It works on, let's say, at the beginning, and you see it some in our price list when you select the hardware. Originally, we had this VIC. This is the data stream input for the software. So depending on what you do, you have the different data streams. And this means for originally video input channel, of course, point cloud is not a video. That's why normally we should change the label. But at the end, we have input data streams, which goes into, as we name it, and you can see it on top, camera viewers. Camera viewers means at the end also to show something which comes from a sensor, either gray color, 3D, thermal, or hyperspectral. It's always a camera viewer, even if you say it's a sensor. So maybe we start with a short intro to the different option of point cloud collection systems or sensors. And so basically we have these profile sensors, which we can see. We have the 3D area sensors. There are some like time of flight or stereo vision, which is more the kind of the RealSense. RealSense is a let's say is a multi-sensor system. Or we have shade by shade, stripe light, strip light, pattern projection, LIDAR, and oh yes, 2 times shape by shade. This could be eliminated. And finally, of course, we have different kind of line-based sensors which generate at the end a point cloud or any kind of single profile. So what we here overview about the sensors which the Ivision software supports, and you simply can buy and use it. So you are free to select any of these sensors to do your task. And we start with the triangulation-based systems. This is majority of sensors which are supported right or are used right now from our customers. And for triangulation-based cameras, you have two options. One is a discrete option. It's a more complex and not so often used. And the other one are the ready-made. So you see from the discrete one, we have only a few. The one is from Automation Technology. This is also a real nice picture from Automation Technology because it shows how the discrete sensor, but all others working. That means you have, let's say, camera. In this case, it's a camera and a laser extraction unit in one. The output is a profile, a 3D profile point cloud, a profile point list. And in the computer, it's generated to either an area, a point cloud, or you operate on the profile. But the important thing here is now you see the laser and you see the camera. And if you do it discrete, you have to calibrate it. Calibration, it's not the easiest part, but we do support it with our software also. So if you want to, either you can buy this pre-calibrated from the manufacturer, then of course you're not allowed to change anything from this setup, else you have to recalibrate it, or you do it by yourself using the Ivision software. Yes. Then the same, this is only the camera section. You can think you need here the same like here, the laser from Photon Focus, or you have the same from SICK, the Ranger 3 section. And finally, we just integrated compact sensor from SICK also, which is right now, interestingly, not available in Europe, but in China. So we have a Chinese bigger customer which uses this, that's why we know it. And the other option is, as you saw on the very beginning, I skip back to this image. You see here the camera and the laser. Of course, this camera does image pre-processing, does the laser line extraction. The other option, you could do it by yourself. You use any kind of camera and the laser. And then, of course, you need a tool to do the laser line extraction, and the second to do the calibration. So we made this laser line extraction and also the calibration tools into the Ivision software, so that you can make your own triangulation scanner. In some cases, this might be an interesting option, especially whatever hardware you use. So this is only one example hardware, because it's a very cheap one. You can use also, as you can see here on the bottom line, any kind of USB, MIPI, GIGI, QuarkXpress cameras, and do this laser line extraction, do the extraction later on in software. The major difference is related to the other solutions. These are not so fast than the fully integrated ones, but in some cases, if you do metal bending and you want to, or you do some slow processes, maybe up to 100 3D measurements, or depending on the image size, this camera, for example, this camera, but also if you have a QuarkXpress camera, you can get up to 500 frames per second, means 500 profiles per second. Of course, these ready-mades are all faster, but anyway, in many cases, these normal cameras are fast enough, and then you can do the solution simply based on your own hardware. The software has all the instructions. That's interesting. Software has all the instruction integrated, which you need to make the 3D solution. And So in this case, the next step is, these are the discrete setups. And if you build your own machine or you have a special need, you can make your solution based on ready-made, on these special components. In this case, if you use in this case, Raspberry Pi with the Raspberry Pi camera, you have a camera which runs, let's say, at fastest 200 frames per second, and you can do the Ivision pre-processing of the line extraction here into the Raspberry Pi and send out the data directly through the Ethernet port to your, let's say, 3D computer. Then you have a very cheap 3D sensor. You can also do the point cloud acquisition here inside, so that you have a ready-made 3D point cloud operation tool. This is all possible. Let's go one step ahead and have a look to the ready-made pre-calibrated 3D sensors. These are especially for high resolution tasks our current main sensors which are used by our customers. And as you can see, we try to support all known 3D compact sensor manufacturers. Of course, if you need some special sensors from Asia, we have some of our customers, some of our users, which integrated some special Chinese compact sensors. So I don't have it on the list because they are difficult to get in Europe, but price-wise they are sometimes interesting. And if you're interested in this, let us know. So basically we have the automation technology, the interesting, so you see here, this is the laser on the left side. I hope you see my cursor. On the left side is the laser. On the right side is the camera, and everything is a housing. What is the advantage of this? The real advantage is you cannot change anything on the system. That means you get it pre-calibrated, you screw it at the screw terminals to your machine, and it works immediately. And nobody is able to, of course, if you open it up, but we assume you don't do it, nobody is able to change things, and you can measure it. And if it's for what reason ever, maybe someone uses a hammer and destroys it, you can replace it and you can work ahead immediately without doing any calibration. And here is another option. You get it also from most manufacturers. We don't have all the pictures. In this case, we have the picture. This is a dual camera version with a laser in the center. This has some advantages if you have very deep objects where you have shadowing of the one camera, so you can use the other camera, and you can combine these two point clouds to one point cloud, which eliminates this shadowing. So the software supports it. So you are free if you have this kind. Some connectors have this deep plastic around the connector pins. There it's very helpful, and of course you get it from most of the manufacturers. Here is a standard scanner. Most of the scanners has different speed, different range, and of course the price is different. So as with all our other products, we try to support as many hardware components as possible to give the customer the option to select the right one for his task. Or maybe because you use always these sensors, you're free to use it. And finally, we have also from LMI, or the Saturn 3D is from AIC. The nice thing from the Saturn, only to round it a little bit up, is it has dual core ARM CPU inside. It's a Xilinx, and you get it with two different versions. To make it simple, this sensor is open to run the own software on Linux, and because we have Ivision on Linux, as you could see it also on the Raspberry Pi, we could run inside of the sensor the complete software, which enables you to make a iSense 3D profile or in principle only a profile due to the limited memory, but you can make real 3D smart sensors. So that means you only need the sensor and then you can do everything in profile. Finally, from our standpoint, it's right now one of the cheapest sensors in the market related to all the others which we support. Of course, there are some cheapers in China. And here are some other manufacturers where the CPU, where the access is not open, but the output is always a point cloud, which allows you to transfer it to our main computer and use the Ivision software to evaluate it. Of course, with this one here, you can also run it as a simple point cloud sensor. Then a point cloud is transferred to the main system and is evaluated there. So these are the profile sensors, and we simply do work on it to have some additional profile sensors which are worldwide available. We try to support all these. A nice other point cloud device is the focal spec. Meanwhile, it belongs to LMI. This is based on confocal optical system. It has some really advantages. Of course, that's what I told you before. If you have a task, you want to solve it with a sensor and you don't know which sensor fits. So then we have a good overview what sensors are available and for what they are good. Especially this sensor, if you have glass and metal and you have to get a point cloud from glass and metal, you are very happy to have this one. This works. The laser scan sensors doesn't work because the laser sensors have a laser sensor go into the glass and you don't get a surface of the glass. Finally, we have the time of flight sensors. For the moment, we support from Basler, from Becom. They have the different versions, also from Becom, the different versions, or finally from Lucitelius. You have these different time of flight sensors. And these are area scan sensors. Of course, I forgotten to tell you, I think it was obvious. The laser line sensors, but also the focal spec generate lines, and you collect the lines to a point cloud, or you operate on the lines. With the time of flight sensor, you have an area sensor. You get, in this case, 20 or more frames per second of point clouds on which you can operate. And depending on the needs you have, you can select which manufacturer fits best for your needs. So if you have, what we also support is, we have this SDK to easily integrate additional sensors. If you have any sensor which we don't support and you think you need it, let us know, we can do it. In this case, we also integrated some new sensors, the other, let's say, 2D sensors from Kien's last 2 weeks. You will see it in some of our news in the next days. So you have some more sensors. And of course, some other area scan sensors are the shade by shade or stripe sensors. Here you see some from Bangalore or from LMI, and of course from Civit, Photoneo, and finally, of course, this one is no longer available. You have also the one from Lerian. It's a German manufacturer. So whatever fits best for you. And of course, we have also the cheap sensors. I mentioned it in the very beginning. We support all the real sense sensors based on here these, let's say, stereo IR pattern matching system with included color sensor. We saw it. or the latest development or the latest release is the LiDAR sensor, which has a real nice resolution. And of course, the two RealSense are right now, in our opinion, the cheapest 3D sensors you can get in the market. Of course, I'm always interested if you know someone who have a cheaper one. We are always happy to find it, except maybe if you build it by yourself, for example, with Raspberry Pi, for example, it might be cheaper. And of course, we have this N0 sensor or the special line scan camera from ChromaSense, which generates also for limited set depths, generates a very high speed, high resolution 3D point cloud. Yes, finally, that's a short overview about the Ivision, the supported hardware. And let's say the first step, if you have selected the right hardware, is you install the Ivision software. And if you have installed the Ivision software, the first the important step would be next. Then after you installed, you get these two. I mentioned, I will show you in a second what it means. These two Ivision versions, but the first step is always, if you have installed it, you go to the hardware configurator, where you can select, okay, now it should open up, maybe, here we are. It's not on this screen. That's, that's now a problem because let's close this one. The hardware here we are. That's nice. So I don't know, the splash screen was not didn't showed up. So you see here, these are all the different manufacturers which are supported. That means you can use the native driver of these manufacturers. Of course, if it's GigE, you can use also our GeniCam interface, or if you, depending on if you have Windows, you can also use Direct Show if it's a Direct Show based camera, or on with Linux, you can use the Video for Linux interface. If you want to test mostly 2D, or if the driver is anyway installed, like if you use, for example, RealSense, it's automatically grabbed from the main website from Intel, and you can use it directly. So you simply select. For the moment, it's called. We will rename it for the Ivision 4 version. This is the Intel RealSense selection. So you select this one, you follow up whatever hardware you use, you follow up here the instruction how to use it. And of course, if you have an I/O system, you select an I/O system, or you select offline if you don't have, and then you can use the software with the hardware you have selected. Of course, you can grab images also with the demo version. I think this is one of the nice things. Ivision works also completely with the demo version, grabbing images or doing I/O. If you use offline, you get I/O simulation. If you use one of the I/Os, you can use these I/O systems for your task. Or if the camera has an I/O, you select camera I/O, and then you can use the cameras. Especially most of the 3D cameras do have an I/O. So if you only need one or two PLC I/O lines, you can use the camera I/O. You can also add, of course, or combine all these I/Os with the normal communication over Ethernet, like Profinet, Modbus, TCP, or Modbus RS-232, or whatever. So let's have a look back to this one. And of course, at the very beginning, I said I do a short intro to the Ivision before we do measurement in 3D. But what I can do before we do the intro, I simply open up this one of the projects which I showed you before at the very beginning of the session, that you see what the software can do. So I think you remember the image which I opened up at the, or the screenshot which I had. So here you see this is now a real point cloud. Of course, you can get also a surface display of it, and you see how it works. I think there was a question. I don't see it for the moment. So yes, maybe the next the question is coming up in a few seconds, and then I find it. Okay, anyway, let's go ahead. So what you see here is I just opened the project. At the very beginning, I told you this is a general purpose software. That means you have always the same tools for the same software for whatever you are doing, and you have only two different versions. The one version is the one I started right now. This operates on the computer in front of which you're using, and the other one, and that's why if we go to the main screen, the other one is, it's called remote. This allows you to remote control a computer where you run only a runtime. Mostly this could be any computer, any x86 or ARM system, but originally it was created or designed for all the smart systems, like the smart cameras, which I showed you at the very beginning. And also you can use these small embedded systems to use it for for the 3D section. One example is the smart 3D sensor iSense 3D, which is programmed because it's only connected by Ethernet, over Ethernet with the remote version. I open it later, you will see it looks nearly the same. You have an additional menu to connect to a remote system. One of the advantages is you can parallelize all these stuff you have while you use multiple runtimes on one PC, either on a remote PC or on the same one, to do the same stuff in parallel from different cameras, or you do it in a daisy chain, you do pre-processing to do things faster or whatever. This is a special section. I mentioned it in the first two sessions, only that you keep it in mind. You can really parallelize multiple of these programs on one system to make things faster or to operate on multiple cameras. Therefore, we have a special section, and also we have a YouTube video. Or feel free to contact us, and we can explain you how to do this. Of course, all the software tools are programmed as parallel, that they use the parallel capabilities of the Ivision software, so that we use the maximum out of the CPU if it's possible. Yes, so let's have a short look to the Ivision software and the parts of it. Of course, on the left side, maybe we have a look to our presentation before we go ahead. Yes, what's interesting is in our current in the 3D side is, as for all other systems, you see here the image capture tool. Whatever camera you have only this tool. You don't have to use another tool if you don't want to. The tool knows, based on the data stream, what kind of camera is connected to this data stream, and captures it into the camera viewer. So You don't have to think, oh, this is a 3D camera. Does it have how to make it? You have only this tool. Of course, behind of this tool, if you have a connected camera, you have access to all the camera parameters. Right now, I do this webinar based on pre-captured point clouds. That means I didn't have connected right today camera. So we cannot see, if you go to the camera settings, right now we see for the camera settings my built-in webcam. And you see here for the webcam, the camera parameters. If you have a 3D camera, of course, you see all the 3D settings, like, for example, if it's a laser camera, triangulation-based camera, setting up the laser system, setting up also the stuff you see here, like brightness, contrast, and so on. If you have a GigE-based camera, you see the complete GigE vision tree with all settings the manufacturer gives you to control the camera. Most of the 3D sensors are GenyCam based, so you have a full GenyCam tree and full access to everything. And of course, you have also the option to control all these from within the camera, that from within the software. Of course, there are different ways to do this, but mainly you can use the tool here. And I show you later another option, which is also really powerful. I cannot show it to you in detail, but I really recommend to use the online help and all the YouTube videos. Another thing is, so these are the camera settings. As you can see, it's only connected one camera. You can connect different cameras from different manufacturers with different data streams. That means you can connect to one system a 3D camera, a gray camera, and a thermal camera, or whatever combination you like to make your solution. You're totally free to mix it up. Whatever you need for your task, you can use it. And to connect the different input streams, as I told you, based on the history at the very beginning, it was called video input channel. Of course, the point cloud is not a video input channel, but it's still handled as one name-wise, but in reality, it's it's a different data transfer. That's why I prefer nowadays the stream. And what is really important, that's why you have this menu. If you have multiple cameras, you can connect the device and the input channel to one line, so that if the system restarts, that of course you get in the right image memory always the right image data. Or if one camera is not working, then you get a black image there, and not captured image there, that you are sure. Of course, you get an error message, but you're sure you don't operate on wrong images. So this is a short intro to the camera settings. Please have a look at it, and later I come back to this. If you want to control everything in the software or from outside of the software, you have the option to control each of these either with the camera control tool or, and this is really powerful, you can use either the built-in script interpreter. This is an own tool. You can find it here in interpreter control, script interpreter. You can program it in basic syntax language, and you have access to everything. So here, this is the first option. You have access to the camera parameters, but you have access to all the tools within the software, not only the camera parameters. And here you define what you want to do. Of course, you have all the basic control to all the basic syntax, so you have the access. But to access the camera parameters, you get here a short snippet that you don't have to think about it, how to do it, because you have it here. And of course, besides the script interpreter, there is also, it's called PConLAN. It means simply control the software from a remote connection. We named it PConLAN. And you can also change, for example, the camera parameter from one of your PLCs. If the PLC can send out RS-232 or Ethernet data, then you have here a snippet and you can send it from, let's say, in Europe, it's very well known and often used, the Siemens PLC with the Ethernet option. You can send out this string and you can control, for example, the camera width parameter or whatever parameter you have selected. You simply copy it from here, send it from outside, from your PLC, from your whatever main system, and you have control of it. This is really powerful if you want to adjust things in the Ivision software from inside or outside. Yes, this was one of the important things also to the Ivision software. Of course, you have here a lot of application parameters. I told you I do it now only in a fast way. You have also control to all these kind of the TCP/IP, and if you want to use OPC or whatever, you have here the control panel to set up the complete software. Especially also if you start the software, what should the software do when it starts? So it does nothing, but you can also say go in auto start, load up this project like this one, this project file, so that you are ready, that when the power goes up, the system starts up and you are ready to inspect whatever you do in the machine. Of course, you can also do a program change from remote over PConLAN. This is a very powerful interface. You have a complete description for it. If you need help, I always can recommend our context help. It opens up here, and whatever tool you click to, you will find in a second immediately the complete description to this file. So I can recommend to open this if you don't know how to use a tool in the Ivision software. Simply start the context help, and then you have the information you need. Of course, we have also installed the manual here as a PDF. So you have a complete PDF manual of the software. Of course, if you prefer a printed version of the Ivision manual, we have one on Amazon. You can order it from there. So it's a print-on-demand version, because most of all the customers prefer right now not the printed one. Of course, the software is changing fast, so we have to change also the documentation and to print it all the time. It's not state of the art, I would say. So we have these application parameters. The project settings belongs to what you saw. If you generate a project, you get everything you need to the project. What means a project? It's really a powerful tool, and it helps us to help you. If you work with the software and you need some support, simply feel free and let us know. And the easiest way to let us know how to do it, or if you have an error and it's not working, you generate a project. That means if you start with something, the first thing what you normally do is you say create a new project, and then you can give this a name. So we say today web 3D and test, for example, and we say okay. In this case, he sets up, as you see, an empty file and also a new camera viewer. But more important, first of all, you see the project name here, and that helps you always to find the project. You go to show data directory. Why do we have this? and why I recommend it. Of course, we have the software on Windows and we have it on Linux, and this means the program data directory are different. Even on Windows, it's not easy to find because it's a hidden folder for the project data which are supported for the program data, which Microsoft says you should store it. And of course, you can switch on the show hidden directories, then you see it, and then you can navigate to it. But the fastest way on all systems, either if it's Windows or Linux, and especially also depending on the different distribution on Linux, the location is different, you use this show data directory, and you immediately arrive where the data directory from Windows is. It's like Microsoft suggests, you should do it on program data, and then you use your company name or the product name, whatever. We use the company name and Ivision because we have these different options to generate the Ivision software. So you find this here, and then you find all the information of the software. And for the moment, with the Ivision 4, it's not called devices, it's called projects. You go to the devices and you find the projects. And of course, here we find the Today Web 3D test. This is a project we have. And if we open up it, and that's the important thing, you find here a set of folders. And this set of folders contains everything of your project. That means if you can send us a project, we can open it also on our side and can see, maybe you use a wrong calibration file or whatever. Because all the data to the project based on the camera, on the settings, of course, if you store some images in the project, you find here the images. Let's go back. Let's go back to the. Maybe you remember I opened up at the beginning this 3D area measurement project, and here you see we have a complete set of, it's the same folder set because it's automatically generated. Of course, if you have documentation which you want to share or you need for the project, you should store it here. We don't put things into the documentation automatically. Normally you store in documentation everything what belongs to the project you want to solve. But important, here you see the 3D point clouds. That means let's open up the project I had already open. We go to webinar and we go to this project ini, and of course we have to run it once. And now we see because we have the software have automatically a set of point clouds or images. Point cloud at the end is a kind of image in our terminology, or let's say it's a stream, data stream, if it's very totally abstract. And each time, in this case, because this the image capture tool is in the option load image, you see we have the option capture image. Now we are in the option load image, cyclic complete folder. That means each time it's executed, it loads the next file from the folder. So you can simulate a complete manufacturing process if you have stored the different point clouds from the machine, and then you can totally offline test it. Or if you say, okay, it's not working for what reason ever, you store first a few of the images, point clouds or whatever, and then you okay, I go back to this one. I closed, I think it. Then you go to your project file. In this, either in this is the new one which I made, or this one, and you simply make a zip file out of it and send it to us. We can open up the zip file. We have all your parameters, all your settings, and can see, okay, that's wrong. Okay, you should change this or that, and we change it for you. Write you a short mail, send you the zip file back with the correction, and you're good to go. this is the easiest way to support you to make a solution, or if you have problems. This is one of the things what I really recommend if you stuck anywhere with doing solutions with the Ivision software. Simply feel free, send us the zipped project file you have made, and we can help you, and we are happy to help you. We have a support team which has all the knowledge and gives you a quick idea what would be our idea how to make it. So so far to the support section, to the how to get support from us. And of course, now you saw here, this was a tool. I just we just had a look to the project settings, and of course you have also this the option to make user interfaces for the different project files we have. We do not always a nice user interface, but you can, of course, you can download all these examples. You should have anyway the download link right now. If you don't have it, simply write us a mail, but it should be part of the invitation to the webinar. And to show you a more or less nice user interface, I use this web gear. To give you an idea what you can do, or how you can create a kind of interface, a user interface. So in this case, we made a start and a stop button, and of course, if you activated the user administration tool, you can do all the kind of user administration here, which allows the user not to change the different levels. Here it's not activated, so we can change it, only to explain why we don't have to enter passwords every few seconds. But what we see here now, it's also important. On the right bottom side, you see license information. It's a demo version. And as I told you, all the tools are working. Also the image capturing tool are working completely. No restriction, but we have a small restriction, of course. The demo mode means you can run it 90 minutes, then you have to restart it. Of course, you can store all the stuff you've made, so you can restart and go ahead where you stopped. And the other limitation is the I/O capability. Whatever I/O you are doing, either if it's PLC, if it's image transfer, if it's TCP/IP or whatever, in demo mode, we do it not always. We do it for a long time, but sometimes we don't do it. But so you can simply also test the I/O stuff. But each time we don't do it, we simply not only don't do it, we tell you, okay, look, in this case, we do an image transfer. If we run it a while, you see now, in this case, maybe some 2 times consecutive, it's not done, and the third time it's a minute or 2 minutes later. So you are able to test it, but of course, if you want to connect to a machine and you want to select between do a good bad decision, it makes no sense to use it in demo mode at the machine, because you only see, okay, we want to set the output, but we didn't do it. It makes no sense for a running system. So if you have the license, then this vanishes, and also the I/O is working completely. This is only to explain it to you, but of course you see here, this is, for example, the start-stop button. You can color the buttons, change the size and everything. You have to check it by yourself. So you could also do, if you have a second level between the programming, or a third or fourth, that belongs to the user. You can make, for example, here an easy, let's say, machine user interface, where you can, for example, change the search diameter, change the number of tools or whatever. So you have sliders, spin boxes, and all this other stuff, which you simply can use to make a nice user interface. Or at the end, you can also go to the integration mode. You can put passwords behind of each of the buttons to prevent that everybody can simply change. The idea is to make it safe. You can also store all these changes in a log file. That means if you give someone a password for a level and he does some changes then here in the either in the programming environment or also with the radius, you can also write a log file about it. So that means user Müller logged in on 1035, changed the radius to whatever, so that you have, especially if you want to deliver to the FDA or so, you have the necessary documentation, or you meet the needs of the FDA Chapter 25 Part 11 to what's needed to deliver to this industry, to the food and drug industry in the US, but also for Europe it's sometimes interesting. You can also select what you want to store in the log file. I only want to mention it because in Germany we have a very high DSVGO data protection, and if you store everything always, then it's difficult. So you can switch it off and don't store it. It belongs to the one who does the setup for the complete system. What is stored in these cases? Only to answer the question for all German attendances here. Yes, so this is one of the support options you should have in your back if you need support. Of course, I showed you here the example for the user interfaces. Of course, you have a lot more options than only a few buttons and so on. You will see it in the demos we have in a few seconds. What I want to show you for the in this moment is what you also have integrated. You have an integrated web server, and if you set it up in the application parameter menu, we had it before, and you activate everything, you can simply connect to the different devices based on their IP address. If you're on the same system, then we have the local loop. It's 127.0.0.1, if I'm correct. No, I just forgot it. And we used this one here. And then you get, for example, here immediately a fitting web interface. And you only look to the machine and see what the machine is doing from any from any position of the factory, or you can also control the parameters. That's one of the reasons why I showed you that you have full access to the different parameters. So in whatever condition we are here, you have the full access to the software based on the wait a second, I have here a chat request, I think so. What's that? But I have to leave. Okay, someone wants to leave us, unfortunately. So yes, the option to use also the web interface is for all kind of solutions, not only 3D available. So simply try it. And let's go. And of course, you see, you can also eliminate everything. And in this case, you need a button to go back to the main menu, which can be protected based on the password protection. So let's go back to our 3D for further investigation. You see here, I didn't make any kind of buttons. Of course, to show you how to make buttons is also a very straightforward way. You simply say, for example, I need a start button. Then you simply open up the start button. Of course, you can change the name and everything, and it's immediately functional. It's running now. Of course, 3D takes a little bit more time. Of course, if you have only the point cloud In this case, it's a scanner. You need the time until it's scanned. You see, but anyway, even for loading the point clouds are mostly really big. Also for loading point clouds, it takes some time. Maybe one interesting thing is for point clouds, if you load or save it, you should remember, if you select a point cloud, here the options which you have. And as you see, we have the E3C. We always, especially also, let's make a new file here and grab this tool. That's how you program. I wanted to show you at the very beginning, but then I said, if you do save image, whatever kind of image, either in fixed file or continuous, this was the option which is used to have this multiple files here. You have on the bottom line the option E3D or E3C, or of course PLY. This is the general 3D point cloud. If you compare the size, I highly recommend to use the E3C. This is a compressed file format, lossless. We don't lose anything. So if you store the point cloud, it's exactly the same you got from the sensor. But if you compare this E3C point clouds with either the uncompressed or even with the PLY, it's also uncompressed, you will see some in the average 10 times bigger. And because point clouds are mostly, if it's not from a time of flight or camera, if they come from triangulation sensors, they are most really big. So here we see it's 7 megabytes. That means if it's in the E3D or PLY, it's roughly 70 megabyte. And of course, we also have some point clouds with 500 megabytes. And in all these cases, E3C is a good option, especially also if you want to send us the file in a, you want to send us the project as a zip file. If you don't want to exceed your post transfer options. So now I gave you a rough idea about how to store also the point cloud so that they are not too big and you can easily transfer it to us. Another thing, so for example, if you have problems sometimes, and we see it always also with the camera, maybe with the drivers or whatever, we have this support file. This is also very helpful, and I recommend it if you have a problem and you say, okay, I set everything up, but the camera is not working or whatever. You should use this create support file. This support file contains, of course, the zip file you normally generate to get support from us. But more interestingly and important, in my opinion, is, or for us, it's important, we get also all the log files, and maybe there's a crash, which we never hope, but sometimes happens. We get also the crash dumps and everything, so that we really see what's going on your system, and we can help you very fast. So I highly recommend, if you only need support, generate a zip file of the project you made. If you need support about camera setups, camera not working, driver problems or whatever, it's always good to have a look to the to generate these support file and send it to us. And because we are just in the debugging way, only a short info, we have this log terminal. This is, I highly recommend this if you start with the Ivision software and you say, okay, whatever, for some reason something is not working. Or even if you look back to your program and you want to see what happens before, you can see here the results of the different commands which are executed. You see the time they need. Of course, you see it also here in the program editor, for example. So image load from, in this case, from an SSD is 7 megabyte. It simply takes 800 milliseconds. Of course, we use the compressed file. This means This needs a little bit more than uncompressed, but it saves a lot of space. If you have any other problem, you simply can go back and you see you can send us also this log file. From startup, you see all the different things that the software found during setup. So if something went wrong, for example, this is a nice example. I use it always. Sometimes I use a backoff IO here on this PC, but right now I don't have it. So the software tells me I cannot support backoff right now because the DLL is missing. So you get here all the information you need if something is not working, what might be the problem, and of course, if it doesn't help you, you can send the log file to us, and someone have a look at it and tell you, okay, look, you should do this or that, and then it's working. So this so far to the log file. Let's go finally also to the 3D. We started with, this was our last thing, with the image capture. So we have this image capture, which works always, and you can use it. And of course, because we have sometimes some special needs for profiles, we have a special profile capture, which allows you to capture profiles from point cloud as an option. So you will find this in the profile section here. And as I mentioned before, we have this option to build your own 3D. Sorry. To build your own 3D scanner, then you have to extract, first of all, the laser line. So we have also the laser line extraction. In that case, you use the image capture to get an image, and the laser line extraction to extract the laser line, and then you use our calibration. There's a description how to make it. It's not too easy, but it's doable. And then you can calibrate your own 3D triangulation system, either with the standard components from one of the manufacturers I mentioned before, or with your whatever USB 3 camera or CoaXPress or whatever, and your laser, you are free to build it in any kind of setup. The tools are here. The calibration tools are part of a menu. If you are at that point, you should connect to us and discuss it with us how to make it to get the information. So finally, we have the tool set on the left side. Let's have a look to it, what I want to tell you. Yes, you have a tool set. Then one thing is, and you can see it here, we have the, of course, the main thing was how to do measurement in point cloud, or maybe in a 2.5D image, 2.5D image. It's a depth image, or what is the advantage of using the some of the hardware generate also an intensity image, which is really nice, and or maybe also some generate a color or gray image like you saw it on the RealSense. Let's go to the software and have a look at it. And here you see this point cloud, and we do the measurement on the point cloud, and you see here, of course, we have done the measurement. We calculated the center point of these two tubes and measured the distance between these two tubes. So it's really similar to 2D. The only advantage is, not the only advantage, one of the big advantages of point cloud is you can rotate the point cloud. Maybe you saw it. So these are images from the machine, from a real machine, and due to some constraints of the machine, the sensor couldn't look down straight down to the part. So this is the point cloud, how it is captured, And the nice thing is now, because we have a point cloud, we can rotate it so that we can operate on the point cloud in an orthogonal way. You could also do it, because the tools don't care about it, operate on the non-rotated, but for the user it's mostly nicer to have rotated it flat. This is one of the advantages, because the depth image which comes from the sensor is still unrotated, because it's the information, and the uncalibrated information of the sensor. And in this case, we do first of all the rotation, and then we do the measurement in this, and that works pretty good. So if you need the point cloud, you could use either from the sensor the depth image. So unfortunately I didn't. I didn't yeah. So the other option here is, now you see this is I only do the load image, and then I generated depth image, and I have to explain you a little bit more about this software. So, but let's see first what it does. So if we open up this the second image memory, which I've done now, you have a different option to do this. First of all, either you do a double click to the free space, or you simply say new tab, and then it's also generated. And if you have a new tab, let's say here we generate a new tab, so you can switch between the new tabs. And as I did it now, you can simply grab it with the left mouse button and tear it from here, and then you have a second image. And you can also store it so that these images are still you can have it in your user, in your GUI, which you can build from the software. I think I mentioned that you can run the software in the background as a runtime system to embed it in your user interface, so that nobody sees that the Ivision software runs in the background. I think I mentioned it before, but maybe I didn't do it. And here, the interesting thing is here now, this is the original point cloud, and we generated out of this point cloud a gray image. And as we can see, the gray image is exactly how it's captured. And we have, it's difficult to operate on these images. So that's why if you want to measure in the gray image, it's working in the depth image. That's why we normally recommend where is it? Here. Normally we recommend this way. And why do we this? Because you rotate it so that it fits better to the needs of a gray operation. You can, if you first generate or use the point cloud, you can rotate and move the point cloud to every position, and then transfer it into a gray image, which has, if you open it here, you see you can first of all define you want to have what kind of gray image do you want. Either you get 8 or 16-bit image. If you don't want to measure the Z height, you can use with the 8-bit. You can operate on the 8. Then X and Y is still calibrated, but the Z value is not correct because it's mapped to the 8-bit, or you map it to the 16-bit. Then you get the Z values like they came from the camera. But anyway, you have to correlate it with the calibration of the camera. If you want to measure, in our opinion, in Z, the best thing is you simply use the point cloud, because in the point cloud the information is anyway available. So yes, maybe to explain you a little bit more about the tools. Of course, why is the resulting image in image memory 1? I know I didn't explain it. And which tool works on what. The image memory means EM, and this column means this is where the tool is either storing or operating on. And so the image, the depth image filter, it's a filter tool, it operates on image memory 0, and the output is in image memory 1. So of course you can change it to 2, and of course you have always the option to say test, and now it generates it to the image memory 2. So of course it's the same image, so you don't see a difference. And you also can do the different ranges. Normally it does the auto detection. That means that's why I said you can measure directly in the generated gray image. So we use the correct resolution and calibration from the point cloud, so that we have a calibrated gray image. If you change the values, then of course it's no longer calibrated, so you have to keep it in mind. If you go from auto detect to whatever you like, you simply change the values. And of course we have also different options how to raster the resulting image. So you have to test what fits best. Normally the default values are very good for your first opinion. Only the main thing is you have a look to the tools and see what fits maybe better to your current situation. It's not always, the presetting values are not always the best values. But this is something you either use the context help, or you use our manual, or maybe you use the YouTube videos. And finally, of course, you are free to write to our support team. So we have a mail address, it's called support@evt-web.com, where you can send, of course, a support file or your sub files, but you can also write us any other question to get an answer how to make it. Yes, so let's have a short look to the program editor, because maybe it explains how it works. Let's go back to our originally measurement task. And of course, you have to activate this task again and run it. And we had a look, first of all, we had a look to the capture tool anyway. If we go in the first column, if you make bigger programs, and then it's helpful, you have always the option with the right mouse button. You see you can set breakpoints. It's really nice if you have, for example, loops or whatever. I think you know how to program. This gives you the option to simply do some debugging stuff. Of course, on the top you see here a cyclic execution or a single time execution or step-by-step execution. If you press this one here, the tool will go to the next step, and you see here the program counter, so that you can see what is executed right now. With the right mouse button you have on the next, this is execution control. This is also very helpful, and especially if you do programming or what program is done when. You can control if the tool is executed always. Then you see these two, are two gears here, these brown things. Or if the tool is never executed, you see the don't drive through sign, the stop, not stop sign, it's the gesperrt sign. And then you have additional some options, which are very helpful if you do some solution for a machine. With the machine. So we have two main modes. One mode is, it's called configuration mode, and the other one is process mode. This should help to make solutions, and do all the programming without the machine. In some cases, it's not so helpful to sit beside the machine. So that's why we recommend always, if you start with a project, you do the setup at the machine and you store some images from the real machine. Simply use the capture image tool, and you capture image from the machine and you save it with the option save, cyclic continuous, or with index, whatever fits better. And you give him the image. If it's a point cloud, you use E3D or E3C, and you run the machine. Then you after this, you have like you saw it here. I think, no, that's it. Yes, that's our current. Then you see at the end, you have this cyclic, and you have, in this case, I think it's 20 or whatever, 20 point clouds. That means from this point, you could go in your office and do the programming. It's mostly, it makes more fun, in my opinion, but it's my opinion. So, but if you go to the machine back, you have to switch. So in your office, you have to use the option like here, capture image from file. And of course, you can say stop or capture from file. And of course, let's say in the reality, you would have here capture image from the camera. And if you're then in the office, you have to do this. And if you're in the machine, you have to do this. And if you have also, let's say, a lot of communications functions to the machine, you have to do it for all communication functions. And in this case, it's much better if you say, okay, you have the process mode and you have the configuration mode, and you can say only in configuration mode. Or because we are here only in process mode. Now it means this command is only executed in process mode. So, and you simply select if you are at the machine, or if you're in your office, you simply change these values here, the configuration and process mode, and then you are sure once the images come from the camera, and you can do it automatically. If you start up, you say start up with process mode, then it runs with the machine, with the I/O system of the machine, everything. Or if you say, okay, I'm not at the machine, I'm in the office, I don't have the I/O, then you can set everything to I/O mode. Then you can, of course, if you have offline, the offline mode activated, you get this simulation, for example, also for the I/O, if you use a PLC I/O. And you can, if you want to check the I/O, if it works, you can also simulate the input and everything, so that you can control, test everything without the machine. And without forgetting, switching on back the I/O or switching on back the image capture from camera. Because this happens by heart. And what you also can do, that's why you see here the debug mode. You can also activate the debug mode, and then you can say additionally in configuration in process mode when the debug mode is also on. That means if you are at the machine and you think, I see only in 1,000 times, or I always in the error case, I want to send a message, Ethernet message to whatever, or store the values. You can simply say, okay, if the debug mode is on, I store it. Then you don't have the overhead to add stuff at the end. So you simply say, okay, debug mode, and then you have the output right now there. So this is in this column. You have to play around with it. I think it's nearly clear how it works. But it really is really helpful if you're at the machine and you have only sometimes some problems or some errors or whatever, what you want to debug. Of course, you can always make a debug, a breakpoint, but if this error happens only once a day, then it might, and it's not so difficult, then it might be enough if you write a text or so. Or you can use these options with all the communication tools. So that means you could also send an email in the error case. You can send it always, but you can say, okay, always if I have this error, send me a mail, then you can sit anywhere and you got the information, what happens or in what case it happens. That's the interesting thing. So of course we talked today about measuring in 3D or in 2.5D, but it doesn't care if in what case you are, you have all these options available. As you see here on the right side, we have this time constraint. How long does the tool need? And you see here this G and T. G stands for graphic. So let's run it once. And so graphics is all this graphics overlay, these arrows and lines and whatever you see. And maybe you don't want to see it from all the tools all the time. Then you have always the option to go to this tool, use the right mouse button, and you can say, okay, draw the line always, or draw it only if it's okay, or if it's not okay, or draw it never. So that if you have 1,000 maybe tools to how it's called, it's unbelievable. You have a lot of edge detectors in 2D or in 3D. Then of course all the tools generate these overlays, and then you simply, if you don't care about the tool, the overlay, you simply switch it off. First of all, it doesn't disturb you. Second of all, of course, it doesn't takes or cost you CPU time. But at the end, if you have an x86 CPU, normally you don't care about this this option based on the time constraint, because it's fast enough. But as I told you, we have also this embedded system, also the 3D profile sensor. And in that case, it's only an ARM CPU, maybe only with 1.2 gigahertz. Then it's, you see suddenly on the PC we have 0 milliseconds, 0.0, and on the ARM suddenly you see, okay, it costs time. So you have the option to switch it off. And the same is the text output. You can switch it on or off. Especially if you don't care, maybe during debugging, it's really nice. Then it's everything is written in the log file. That means all the green stuff came from this text text string, which is generated by the tool. In all other cases, of course, it's based on the system, so you can change this Verity mode. So you see, I switched everything on. It helps if you search for something, but at the end you can switch it off. It saves also time, only as background. That's why you can switch off also these text outputs, which saves time, or maybe you don't want to overload the log file with things which are not really important. And the next column is the invert inversion. So you can invert the result. The resulting column is the next one. This means this tells the system, was the execution good or bad, whatever it is. You have good, bad, or warning in these, and depending on, you can do something. For example, if one of the tools or a tool group has an error, you can print an error. But you also can select one tool and check if this tool was good or bad. You can do a jump. So you have these jump tools to go to subroutines or to another position in your execution to do some stuff which you want to do in, for example, error case. Yes, this is this column. Also, if you use the right mouse button, you can, or you do a double click, you can exclude the result. So this result is not used for a global result. How to make jumps and decisions. It's a yes, I mentioned it in the first session, so maybe you have a look at it. And finally, you have the tool itself. So in this case, this is a Rect Probe. And now you see here, the Rect Probe is here on top. And we measure here the difference of the 3D Rect Probe is that you have to instead of the 2D image or 2.5D image, the gray image, you have not only left or right for the detection, you have, of course, left, right, up, down. So you have to select in which direction should the probe go. Of course, it's a point cloud. And to know which direction, we have here on the bottom, I think you see this, it's not moving in size, but you see on the right bottom this X, Y, Z. This gives you the idea in which direction you want to measure. And here, now if we press the test button, you see we measured this edge here. You see it? And if you look to the coordinate system, and really this is one of the main errors which one is doing if one works suddenly with 3D, you have to look in which direction. Now you see, of course, this is a positive Z. This is our probe. It probes from here to here. And no, this is our probe, and we tell the probe here it's in plus X direction. So we have also show in parentheses the right. It goes to the right. So independently what 3D tool you use, if you do measurement or whatever, you have to think what is the right direction. I know it from myself. If I do a fast demo for someone, mostly I don't look to this coordinate system on the lower bottom, and yes, then it's not working. Of course, if it's not working, simply don't say the tool is not working. Simply think, do I have selected the right direction? Because of course this probe could also probe from the top to the bottom. It would be also an edge. Yes, this is really important to have this in mind if you do 3D programming, to think about the direction. So let's have a look to, yes, we had a look to the column. And in this case, we used this Rect Probe. Maybe a short intro to the probe also. So we saw how the probe is working. And here now, it's especially interesting for also for 3D mostly. If you do a left click, then you will see, if you look to my screen, then you will see the tool is running to this position and then opens up the Rect Probe. So as you see, we need this 800 milliseconds until we to load the image and some other milliseconds to be at this position to reposition the probe. This is, in some cases, if you only want to change some parameters, and if you have a lot of these probes, and especially if you are at the machine, and maybe the machine have to scan this, then 800 milliseconds is the fast way. The machine might scan it in 10 seconds, so you would have to wait 10 seconds until you can go ahead. Then you have always the option to use the right mouse button, and you see the quick edit. And if you now have a look to the Rect Probe tool, you will realize it opens up immediately. Why does it do this? Because the Rect Probe tool, in this case, the quick edit, doesn't execute the complete comments before. This has the advantage, you don't have to wait so long, but of course, the disadvantage is the relations between the comments are not renewed. It makes only sense if you want to change some of the parameters, maybe the direction of the search position, because you saw, okay, this is wrong. For the next loop, I want to have a different direction. or the tolerances are wrong, all the parameters, or you, for example, if you have the proximate angle and you realized, oh, yes, with this proximate angle, it's not detecting the edge, then quick edit is good. In all cases, if you want to measure distance and you need the result from some tools before, then you cannot use the quick edit. But I think you simply test it and you see the advantage of it. So, oh, I don't want to do this. Yes, this one. So if you go to, then we have, this was the quick edit, the show parameter list and show register information. Register information is some stuff which goes into our 2D register information. What is really important or really helpful and also powerful, because it belongs to this script interpreter, which I mentioned before, is the show parameter list. The show parameter list allows you for each comment also to access all the parameters directly. So, for example, here the cone angle, this is the search area. If you want to change this, as I explained it in the camera settings, you can go here to script interpreter and you get here, for example, how to get the snippets to get the cone angle. And of course, if you want to set it, you get it also directly from to set it. So you can, from outside, because you saw, okay, this might be changed, or I want to change this parameter, whichever, you have full access to all the parameters, either from the script interpreter or from the Pre-Con LAN. What is important in this case is, if you look to this section of the code, you see here 3D Rect Probe cone angle, and we use always what you have in the comment section. So what we recommend, latest when you want to access the tool from the script interpreter or from Pre-Con LAN, you should change or you should change the name of the comment section, because this name is used to reference to the comment and do the change. So this is something which I really recommend to do if you want to operate on this. And of course, you have here the also show last result. This is, you use this normally. I use quick edit. Then the result is entered here in the nominal value, so you don't have to think about the right value. This is mostly helpful for, let's say, 2D stuff, when you do uncalibrated whatever work. If you have a 3D sensor and you have anyway calibrated, you know it from your drawing, and you can enter the value here for your nominal values. So of course, I just remembered the comment section. The image memory is it's called image memory, also point cloud memory, or however you, or profile memory. This is where the information is, and important, the resulting values are stored in the 3D parameter data. If you want to know where the software stores all the intermediate values so that you don't have to handle it, so there are different options how to access parameters. Please have a look to this, to our first section. But for 3D, we have this special 3D register. As you can see here, we have the value register. It's used if the command generates a single value, or a point, or a circle, and so on. But for 3D, we have this 3D comment set where you get all the information of the tools so that you can access this information later on. So the 3D register as uses, or the 3D comments uses these registers to store their intermediate results like planes, circles, volumes, and so on. This is the right place where you can find it and where you can look at it. Maybe you also saw, of course, there's a difference. Okay, I close this to have more space on the screen. maybe you saw also here, this is the gray image or 2.5D image. What means is a gray image at the end. You see here also, this is 8-bit because it's gray. If it's 16-bit, you would see here 16. If you go with this cursor, you get all the information, X, Y, and the intensity or the gray value. In that case, it's the height value. And for 3D, you have here some more options. First of all, you have the image tool, so that you can see how is my image. Is it more flat? And where are in what depths are what information? More important is you have also the size of the image. Originally, it's how big? 2 million and somewhat pixels. And you see also the minimum and maximum values. This helps you to get an idea about the image. But if you go back and we can see it better, you see immediately where which parts are, because they are highlighted when we go over this. And so we did a good flattening of the image with the position adjustment. So the position adjustment rotates the image to the right position, and with the area adjustment, you do the flat that it's on the same level. That's why here, of course, you see here, this is nearly exactly the same level. So you can increase the width, and then you see it's only 1%. This is nearly flat scan after the correction. So yes, we are so far. So we had all this information about the tools. The measurement, in this case, it's like in most other 3D. You can, if you go through the tools, you see here, we do now the hole detection. It went wrong because this is we didn't run the complete tool set, and then the adjustment was not correct. This maybe we should remove all the images which doesn't fit for the program for the moment. Okay, here we have a valid measurement, and I switch off now also that we capture new image. In this case, we use the 3D hole position to determine the circle here. And as a result of the circle, we get the center point. And based on that, we can use the 3D distance command to do the distance between the center points of the holes. But you can also use these two, as we have it here, these probe commands. So to determine the edge, and if you use another probe command, I think this one here. So in this case, we determine these two as our new coordinate system. But as you can see it here, you can use these 3D Rect Probe commands and use the distance to calculate the distance between the Rect Probe if we switch on. So I recommend maybe sometimes to switch on the surface mode. Then you see better the Rect Probe generates also one point which can be used to do a distance measurement in the probe. And of course, now we are in 3D. We have here this 2.5D command. Either we go to, I think this one here. Now we have in image memory 0 anyway a good point cloud. So I converted it simply with the image converter to a gray image. And in this case, so here we had the 3D probe. I just showed it to you here. This one, which we used before. So we have to use 3D here. if you operate in a 2D image, you simply go here and you can say reset probe, and this is now, as you can see, a normal gray image probe. You don't have to think about how it's called. So of course we have to say we're looking for a bright image, and we use the first or middle point, and now we get immediately this point as our first point. Maybe we can make it smaller to do the measurement at this point here, and it's the same, and you do now here exactly the same as in the gray images. Means you simply use the tool. Of course, we do the measurement from this side here, and we get here the points from the system. Is it possible that I can get the program that? Yes, of course. I can send you this complete project which I used today. And so now we are in 2.5D, or let's say gray image. I would say gray image, and you can say I want to use a distance measurement, and of course you say point to point. Then it uses simply point to point, register 0 and 1. So if we move it, you get from these 2 points. You could also say we could use it parallel to the x-axis, I think so. Then we have this one, and you get immediately here, as you can see, the resulting value. So you do it exactly like in 3D. So the option is only that in 3D. So now we had an advantage because our 3D program, which I used before, this one here, this does an object rotation and alignment, so that we have here the flat surface, and it's much easier to operate on the flat surface than you do it on a real depth image, which comes directly from the camera. If it's not totally parallel, you have this gray, this bright to dark gray, depending on the angle of the capturing, because it's the depth is moving in that Z direction. With the Z command, you can first of all do the orientation flat, so that you have here a nice flat image. But you can measure it exactly in both, and that's why I said normally why doing a 2.5D image. Of course, there are reasons. I just showed you here not so much about measuring. I sent out this project file with some measure stuff inside, but I want to show you when it makes sense. Okay, not in this image, but let's go back then. If you want to do something real, what you cannot, if you do some stuff what you cannot do in how it's called, what you in a 3D image. Okay, I have to move now my user interface just flipped to my other screen. Wait a second, I have to move it to the main screen. So, and here you see this is a scan from a wheel. It's from a life, from a wheel, from a tire. And of course, if you want to read the tire code, one could make a special tool to do OCR on 3D. Would be possible, but in this case, it's much easier. We take the areas where we have the quote. First of all, we flatten it, so we have no transition in the gray level, and then okay, then it's a black and white image. And of course, on black and white, it's very easy to do OCR. So this is an example where OCR is much more powerful, or it's much easier to work on this. If you adjust even you see here the 3D, even the 3D values, if we let's open it up and do the this one here, you see here, yes, it's half round, and you could adjust this simply in the 3D field. We do the surface alignment, and then after we align the surface, we make the nice gray image and do the image operation of the nice gray images, for example. And I think I simply can recommend you to have a look at it. I see we are at 12:08, somewhat late. But anyway, you should download this, and you see here a lot of examples. For example, for it's still on the wrong display. 1 second. This when you make the user interfaces, you define on which screen the user interface will appear, and at the very beginning. And here you see here an example of how to do inspection and measurement on a pin, on pins, any kind of pin header. And you see here, this is a total program. It's easily made. Of course, we have discrete inspection. This works on all any kind oriented multiple objects like grids, like BGAs, or if you have to count anything which is, or in some case, oriented in a grid, it doesn't have to be always the same n by m. You could also exclude some stuff. It's really nice. So you simply open up it and you see it. Or the another nice example is here. Of course, we have bin picking, or here this is a nice option where we start. Maybe it's also on the other screen, so I have to move it to this position. Wait a second. Here see this is with the real sense, but you could also do it with the TOF camera, whatever fits better for you, or what you want to do. This is the inspection of the rest volume of a box, and you see here, because the real sense has this this color camera, also a gray camera, you could also add at the end of the command or wherever, you could go use the color instruction set here to determine, for example, if the box is blue or whatever, or to read something on top of it. All these things are easily to combine. So unfortunately, I hope you had a short overview about the hardware and the software, and I sent out also the webinar Pointcloud with some measurements inside of it, so that you can see how I did it. But I simply recommend, remember all the demo, the project files, which I just opened one of these here, and you can see this is you can really see how it works with a real camera. But if you have a real camera, if you have a real sense, feel free, connect the real sense to the system and try it with the real sense. Or if you have any of the other 3D cameras,